Welcome grade 8 to another math video, and in this one we're going to take a look at certain quadrilaterals. And I have the textbook here, although I've also provided the PDF of this picture, where it goes over different properties of different quadrilaterals. And the five that we're going to be talking about are parallelograms, rectangles, rhombus, square, and trapeziums. And we're not going to go over these in great depth. And if you want some specific bits of information that check off what they're good for or which properties they have, you can take a look at that pictures about quadrilaterals. But there's a couple of things that are going to be important. Has four right angles. That's going to come up in solving different angles or side lengths. Its opposite angles are equal is another one as well. That's going to come up quite a bit. And otherwise, though, some of the other bits of information are important just to know about some of these quadrilaterals, but we're going to use those in solving these questions. We'll see this more as we go through the example questions, and I think the best way to understand how this fits in solving for side lengths and in solving for different angles is just to dive right in. Again, if you'd like to take a look at the examples on your own, you're welcome to, but for this one in particular, I would highly recommend sticking around and hearing the example questions to help you understand better how to solve some of the triads as we go through. So in the very first example that we're given, example number 10, we are given a bit of a strange shape as well. We're given a parallelogram in that we have two sets of parallel lines. We have one here, one here, one here, and one here. And then we also have lines that cross in the center. And we have different values. So this is 26, this is 2y, this is 3x minus 10, and this is 2x plus 6. And we're asked to solve for the values of y and for x in this particular question. Well, we need to understand how these work in order to be able to solve that using these values. One of the bits of information is that this length here is the same as this length here. They're exactly the same. This line meets in the center. So 2y equals 26. They equal each other, and we can use this information to now solve for whatever y is. Remember that to solve for y here, we need to get this times 2 out of the way. And our way of doing that is use opposite operations, divide both sides by 2, to figure out that y equals 13. Now that we have y out of the way, let's figure out x. Well, just like this and this were the same, this side length and this side length are the same. So 3x minus 10 is equal to 2x plus 6. Now this is a bit of a messier equation, but still something that we've solved this year and that we know how to solve. We need to get x's by itself and we need to get numbers by itself. So let's move over this 2x. Let's move over this minus 10. So we get a 3x minus 2x, remember it changes signs, equals 6 plus 10, that 10 also changes signs. 3x minus 2x is just x now, and 6 plus 10 is 16. So our y value is 13 and our x value is 16 as we were solving for some of the side lengths within this parallelogram. Now let's take a look at example 11. Example 11 also gives us a parallelogram, but it is now asking for us to use information in order to solve for angles. So we again have this. We also have a line running straight through. We're told that this is 35 degrees. We're told that this is x, so we have to find that out. This is y, so we have to find that out. And this is 120 degrees. Well, right off the bat, one of our properties of parallelograms is that opposite angles are equal. So if this is 120 degrees, then x must also be 120 degrees. And we also have created a bit of a triangle here. So 35 degrees and 120 degrees are these two angles. Whatever y must be has to complete the 180 degree triangle. So 120 plus 120 plus 35 gives us 155 degrees, which means that y must be the remaining 25 degrees to get us to 180. You can always double check your answer. 120 plus 35 plus 25 should equal the 180 degrees needed in order to complete that particular triangle. Let's take a look now at example 12. Example 12, we are now given a rectangle. Example 12. And so let me draw out what we have or what we know so far. Some of the special properties about a rectangle, this is y, this is our x that we need to solve, and this is 33 degrees, is that the corners are right angles. They're 90 degrees. And that's going to be the key bit of information that we're going to use here, as well as all of these triangles that are made are isosceles triangles as well. So if this is 33 degrees and this together is 90 degrees for that corner, then x must make up the remaining amount. And so 90 minus 33 degrees is going to give us 57 degrees for x. Now that we have that bit of information for what our x value is going to be, we need to solve for y. And again, there's a couple of ways we can solve it. One of the ways that I'm choosing to solve it is because this is an isosceles triangle. If this is 33, this is also 33, which means that this up here must be 180 minus 33 minus 33, or 180 minus 66, which is going to give us 114 degrees. And if this is 114 degrees, this is the opposite angle to that, which means that that also has to be 114 degrees. So our x is 57, our y is 114. Let's take a look at example 13 now. Example 13, we have a rhombus. And in our rhombus, we have different sets of parallel lines. That we're going to use to solve this particular question with a line running straight through the middle. We know that this is 32 degrees. We're asked to figure out what this y is as well as what this x is. So if this is 32 degrees for this particular question, then we can use that information in order to figure out what this is. So opposite angles are going to be equal. And in this case, it is, because these are the same side lengths, it's as if we created our Z pattern again. And so our interior angle, 32 degrees, is going to be the same as this y, which is also going to be 32 degrees. This is an isosceles triangle. So if this is 32, then this is 32 degrees, which means this must be whatever's left. So together that's 64 degrees. I have 180 degrees in total. When I subtract the two, I figure out that my x is whatever is remaining, which is 116 degrees here. So I know I'm stepping through it a little bit quick, but we're working through a lot of the information that we've been working through over the last number of lessons in order to piece it all together to get these answers. Example 14, our final example here, we actually have a combination of shapes. So we're given a square, then we're given an equilateral triangle that's attached to that, and then we're given an isosceles triangle that fits all of the rest of those together. Actually, we don't necessarily... Yeah. So we're solving for some of these missing values. We're solving for this angle right here, angle x. Well, in order to do that, there's a couple of bits of information that we're going to need to piece together here. The first is that we need to figure out this angle. And this angle is going to be the 90 degrees from this square plus the 60 degrees from this from this triangle, from this equilateral triangle. So that's going to be 150 degrees. And in a previous videos, I've explained how an equilateral triangle, all the angles need to be the same. So to get to 180, it needs to be 60, 60, and 60. For this one, for a square, all the angles are 90. So 90, 90, 90, 90. They're all right angles. So 90 degrees plus 60 degrees would give us the 150 degrees there. Okay. Now, our next bit of information has to do with understanding that this is an isosceles triangle. So these two are going to be the same length. If that's the case, then that means that this angle and this angle are the same. I have 150 already, which means there's only 30 degrees left in my triangle. I have to split it evenly between these 2 points, which means that each get 15 degrees, which means that now I have solved for what my missing x value is going to be. That's one way that you could do it. That in this example is the way that I have chosen to solve this particular question. But hopefully stepping through that will help you go through your try it questions. Please remember that as we stepped through all of these different examples, they also very closely parallel the try it question. So example 10 is just like try it 10. Example 11 is just like try it 11. And if you're stuck on one of the try its, if you're stuck on try it 13, look at example 13, and that might help you solve that particular question.